The need to measure time gives birth to astronomy. To know the date, to know the season, when to sow, when to prepare for winter. Today, skies like these are glimpsed only in remote locations, in places free of lights and pollution. In ancient times, everyone saw the sky and knew the sky. Like their ancestors, the hunter-gatherers of today use the sun to tell time. They know the motions of the heavens. True astronomy begins 6,000 years ago with the Babylonians. They chart celestial movements. They group stars into constellations. They imagine them as figures, the signs of the zodiac. The Babylonians observed wandering stars. We know them today as the 5 nearest planets. Simultaneously in China, astronomers map the cosmos, carefully recording such things as comets. In Egypt, the annual flooding of the Nile is signaled by the dawn rising of the star Sirius. Such cycles may be controlled by their gods, but the ancient Egyptians have good sense. They divide their astronomical calendar into 365 days. Much later in Central America, the Maya do the same, but their warrior god Venus offers an alternative calendar, 584 days. It's based on cyclical movements of the planet. As to the mechanics of the heavens, here's a Hindu view. Our world is supported by 4 elephants on the back of a turtle in an ocean of milk bounded by a serpent. Back in 300 BC, the Greeks are more scientific. They see a series of concentric crystal spheres in motion around the Earth, riding each in its own sphere of the Sun, the Moon, and the 5 planets known at the time, those wandering stars. The background stars are set in the outermost sphere. Midsummer's Day 200 BC. The sun shines directly down a well at Aswan in Egypt. This is known to a librarian, Eratosthenes. He works several hundred kilometers to the north in Alexandria. There, at the same time, a pillar casts a shadow. He wonders why. The reason is the curvature of the Earth. As sunlight shines vertically down the well, it's at an angle in Alexandria. Simple geometry gives Eratosthenes the circumference of the planet and proof that the Earth isn't flat. The Greeks start to measure the sky. The first star map is compiled by the mathematician Hipparchus. He records the brightness of stars. And by observing eclipses, he tries to work out the relative distance to the moon and to the sun. Another Greek, Ptolemy, believes that the planets orbit the Earth. Such is his reputation that the mistaken notion persists for nearly 1,500 years. So how does Ptolemy account for the wanderings of the planets? While the rest of the stars move steadily across the sky, why do those wandering stars make little reverses? Ptolemy's explanation is epicycles, tiny circles described by the planets around their main orbital paths. He's wrong, but it fits his observations. Nicolaus Copernicus gets it right in the 16th century. He puts the sun at the center of our system. Brilliant work for a Polish churchman who does astronomy as a hobby. Copernicus has 5 planets in circular orbits of the Sun and the Moon in a circular orbit of Earth. The German Johannes Kepler refines the idea in the early 17th century. He has 3 laws. The first is that planets orbit the Sun in ellipses, not circles. The second is that orbital speed varies. It's slower farthest from the Sun, but speeds up close to. Kepler's third law is that the closer a planet is to the Sun, the faster it travels in its orbit. Observations by the Danish astronomer Tycho Brahe provide Kepler with the clue as to why planets seem to reverse. Here, blue Earth is overtaking red Mars. As it does, Mars appears to make a backwards loop. The Italian Galileo is the first to turn a telescope on the sky. It is the early 17th century and modern astronomy is underway. Craters are spied on the Moon, the Sun has spots, Jupiter moons. The Dutchman Christian Huygens discovers Saturn's biggest moon, and he correctly observes that the rings of Saturn are detached from the planet. This man identifies a gap in the rings. He's Giovanni Cassini, a French astronomer of Italian descent. His observation is in 1675 and, to this day, the gap bears his name, the Cassini division. The English genius Isaac Newton revolutionizes astronomy. He works out gravity, splits light, and shortens the telescope by using internal reflectors. A century later, William Herschel discovers the planet Uranus, and at Slough in England, he builds the biggest reflecting telescope in the world. His observations are prolific. They're published as catalogues, and he's the first to recognize that the stars of our galaxy form a flattened disk. In Ireland, the 3rd Earl of Ross builds an even larger telescope. Mounted between stone walls, it's completed in 1845 at Birr Castle. The Ross reflector glimpses galaxies beyond our own. Not fuzzy blobs, but galaxies with structure. This sketch, by Ross, is of a spiral. Here's the galaxy today. The 19th century yields 2 key tools. One is spectroscopy, the analysis of light to work out the nature of objects in space. The other is photography. This photo is the bright comet of 1882. In the 1920s, Edwin Hubble brilliantly employs both tools. At Mount Wilson, California, his great telescope records galaxy after galaxy, and the fact that they're all racing outward. Where optical instruments can't see, radio telescopes can. These dishes probe back in time toward the Big Bang, the seminal flash that sets Hubble's universe on its way. Ever more powerful telescopes penetrate deep into space. But the next discovery could be by an amateur. Pioneering isn't confined to professionals. Astronomy is the science of the people.